And software development requirements change frequently, and autonomous platforms are not an exception in this sense. Having well-defined processes or workflows is essential for safety assurance, quality assurance, and compliance with standards, to mention just a few of them. Many of engineering workflows are iterative. Therefore, accelerating the development workflows and maintaining traceability have real benefits such as short time to market, cost reduction, etc. Siemens supports the acceleration of development workflows by software tools, workflow automation, and engineering services. In a project, Siemens focused on virtual verification and validation of an autonomous mobile charging system. The virtual verification and validation have been split into 4 main stages. First stage: requirements specification, starting with use case analysis, operational design, domain description, hazard analysis, and risk assessment, ending by defining requirements according to the applicable standards. The second stage is data recording and analysis. Using experimental data, simulation models are validated. Therefore, data are captured related to the platform dynamics, sensors, and operational design domain. The third stage is modeling and simulation. Different models are built at this stage, such as autonomous platform kinematic and dynamic models, sensor models, environment models, and scenarios. All models shall be validated against experimental data. Nevertheless, sensor models shall be validated in the operational design domain. At the last stage, virtual verification and validation is performed. In the current project, only model-in-the-loop tests have been performed, but the approach can be extended to other virtual tests. At the end, safety assessment is performed and a test report is generated in automated fashion. The test report is linked back to the requirements, therefore the functional test coverage and the traceability matrix can be visualized. Although requirements could change in time, but traceability is maintained and is kept up to date. Siemens support this development workflow with 4 different software tools. Polarion for requirements management. HEADS for design space exploration, optimization, and test automation. SimCenter Prescan for modeling sensors, control systems, and the environment, considering a physics-based approach. SimCenter AIMSIM for modeling the autonomous platform dynamics, considering a physics-based approach. The main interactions among the software tools are shown next. The workflow is split into 2 main phases. Phase 1, preparation phase, where requirements and test preparation are defined. Models are developed, validated, and integrated. Scenarios are defined, built, and parameterization is done. This phase of the workflow is manual, but once this is completed, it can be used continuously or even reused. In the second phase, the scenarios are executed in an automated fashion and test reports are generated automatically. The generated test report is linked back to the test requirements, so the traceability is maintained and can be visualized. Next, the workflow is briefly illustrated in case of autonomous urban mobile charging system. First, requirements are defined and stored in the requirements management tool. In the next step, test requirements and test cases are defined and stored in a machine-readable format, Excel file. Using validated models, virtual tests are run using the Siemens toolchain, considering different scenarios. The test reports are generated automatically and linked back to the requirements. Therefore, traceability is maintained and traceability matrix is always up to date.